Hello everyone and welcome to Virtual User 2024 conference. Our session is titled Unlock Data Insight Faster, the Cohort Builder Way. We will be exploring an ecosystem of Cohort Builder R packages designed to accelerate our data analysis workflow. And I hope after this session, also yours. My name is Adam Forys, and today we will be presenting together with my colleague Krystian Igras. So what is cohort? According to the definition from Wikipedia, in fields like statistics, epidemiology, marketing, and demography, a cohort is a group of subjects who share a defining characteristics. In simple terms, a cohort is a group or subset of the data, where specific inclusion and exclusion criteria have been applied. In our world, it's like filters that can be created using the dplyr, data table, SQL, or any other tools. Let's discuss the key challenges we face over data manipulation in Shiny app development when we was creating different cohorts. First of all, starting each app from scratch was slow and painful. In more complex logic, it was easy to make a mistake. We need to work with different data sources, data frames, SQL database, local files, REST API, even with custom R object with the logic behind. The clue was always about be possible to reproduce the results from Shiny and share the cohort definition. Any existing package that shows up, like Shiny Meta, didn't cover our needs. It was required to work with various frameworks, and it was stopping us from focusing on deliver real business value. Many times the entry threshold was really high, even for technical users. And the efficiency, processing, and building responsive Shiny apps, especially in complex logic, was always a challenge. Many of you seen how reactivity can slow down and complicate the filtering logic in Shiny. We came with the proposal. Our goal was to provide a highly customizable tool that will make it easier to work with different data sources and models. So we have one unified framework. We can share results, cohort state, and reproducible code. The tool accelerates development process and reduces the complexity. Fast prototyping allows us to really quickly collect feedback from the stakeholders and focus on more important tasks. For more advanced use, with the custom extension, we can build support for any data model. For sure, some people will ask, what is the difference between Cohort Builder and commonly used dplyr? The dplyr is one of the tools that the Cohort Builder is using. And Cohort Builder is not another data manipulation tool. It's a layer with the filters meta information. It's not competitive. The Cohort Builder is using multiple R packages to accelerate value delivery, like Cohort Builder DB using dbplyr. The Shiny Cohort Builder represents the first user interactive interface layer. And of course, it's available on CRAN, like many other packages. I hope I have your attention. Now, my colleague Krystian will demonstrate the Cohort Builder in action.
Hi. During the demo, we'll work on patients' data. This is a data model that consists of 4 tables: demographics, diagnosis, visits, and therapies. This is a data model that reflects clinical data that describes how patients were treated for selected types of cancer. Our goal here is to explore how patient treatment lines looked like throughout the time. We selected inclusion and exclusion criteria. Our solution to this case is a Shiny dashboard. In the main panel of the dashboard, you may find the timelines plot for patient treatment lines. The output was generated with Shiny Timelines package, and on the right side we can find the filtering panel. The panel was generated with Cohort Builder, and now I'm gonna explore it to show you what features does it provide. So in the step 1 section, we may find filters attached to each of the table from our data model. let's activate the gender filter and observe only females and missing data within the variable. What's more, let's choose only diagnosis A and B. Now, in order to apply the filters, we click Run All Steps button, and the output updated on the filtered data is rendered here. So that's simply it, but let me show you what other features CohortBuilder has, the filtering panel has. The CohortBuilder allows to perform multiple steps filtering. So after we click Add Step button, a new filtering step will be rendered. That is fully based on the data resulted from the previous step. So as we can see, we don't have a male option over here, but we can apply another filters. So let's say we're interested only in lines from 1 to 3. We click Run All Steps again, and the output is recalculated. The filtering panel presents also some basic statistics for both for the tables and for the filtering panel options. What's more, we get the feedback plots for numerical data. We have histograms for the discrete ones, the simple bar plot with presenting how many values fits into the group. What's more, the filtering panel generates attrition data. This is a step-based attrition that shows how many patients were excluded in each filtering step. This is applied to each of the table. And the last feature that I'd like to show you is reproducible code. When we click the button, the code is showed up that you can just copy paste into the console and have the same data as resulted with the filtering panel. So now I will show you how you can use CohortBuilder, how you can generate such filtering panels and include them in your Shiny dashboard. Let's start with loading the package, and in order to start the package configuration, we need to create two objects. The first object is a source that is created with setSource function. Source itself is the R6 class object that shortly speaking, stores the pointer to the data that you want to operate on. In our case, and by default, the CohortBuilder operates on a list of tables with names called tblists by the package. So as we can see, a tblist is a list of 4 data frames with class tblist. And after we call setSource on it, the source will be created and we can move forward. So then we create the cohort with cohort function. As a first argument, we provide the source so that we know on what data should the cohort operate. And we can also provide additional configuration, and what we're interested in most is configuration of filters. Filters in CohortBuilder are created in filter panel. It offers multiple types of filters meant for different cases. In our case, the gender variable filter from demographics dataset will be filtered with discrete filter, and the value that we want to apply is female only. For line number, that is the second filter we would like to use, we use a range filter, and as an argument range, provide from 1 to 3, so we will observe only 3 first line. Let's create the cohort. We can see it's an R6 class as well, and as a first function, the control function for the cohort configuration is SumUp. With SumUp, we may quickly see the cohort configuration. Here is the list of filters and filter arguments. And what we may observe, all of the filters were automatically passed to the step number 1. And what's next? So the filters configuration is not applied automatically while creating the cohort. In order to run the computations, we should use the run function on the cohort. So now the data was recalculated with the filters applied, and in order to get the resulting data, we call getData function on the cohort. So let's quickly check. Therapies, line number. Yeah, only lines from 1 to 3 are here. So now let's extend the example. In the CohortBuilder panel, we were creating multiple filtering steps, and this is also achievable while creating the cohort. It's just enough to wrap the set of filters with the step function when configuring the cohort. So in our case, the step number 1 will have filter for gender and for line number, and the step number 2 will filter last seen variable from demographics with the date range filter. Let's create the cohort, run the filtering, and in order to get the data from the specific step, we may provide the step number to the getData function. And yeah, for demographics, we observe only females. After the first step, after the second step, we may see only the last seen from 2022 is here as we've provided for the filter. Now I will highlight some other methods that you can apply to the cohort. The first one is our support for the reproducibility. So with the code function called on the cohort, we may get the reproducible code that you can just copy, paste in the console and generate the same data as the cohort itself. The reproducible code is using the backend functionality. In our case, it's dplyr for the TB lists, so the dplyr code will be returned. And this is it may look a little bit messy because we're also adding some internal methods, but these methods might be turned off if we don't need them in the reproducible code. So here is the improved result. We may see the dplyr is used here for our goal. What's more, in terms of reproducibility, the getState function might be used to return the filter configuration. So let's check this example. We call getState on the cohort with the JSON true, so we would like to see the cohort configuration as a JSON format. And here is the full configuration of our cohort that can be then passed to somebody else and then restored with the restore function to create the custom cohort. So this is the other way to share the result instead of sending the whole filtered data set or sending the reproducible code. So in our case, let's take the returned state. We can even modify it. For example, let's choose gender as male. Yeah, gender as male. And with restore on this new configuration, we applied new filters, the new definition, new configuration of the cohort, and we can see only males were returned here after the first step. And for the attrition, we can call the attrition function and the plot will be returned. Now let's move closer to applying CohortBuilder in Shiny. For that goal, we will load shinyCohortBuilder, that is graphical extension to CohortBuilder API. Let's load the package, configure the source, configure the cohort filters, and with the GUI function, we will open a simple Shiny dashboard having the filtering panel based on our configuration with the highlight of data on the right. So let's configure the filters in our way. Yeah, and after we close the dashboard, the cohort will be updated with our settings so that we can get the filtered data. For the function itself, we have many additional arguments, but one of the most useful one is the run button. So with the value local, it will add a simple play button to each step. After we set the configuration, we play the button, and then the data is filtered. Also, the run button as global will add the global run button to the filtering panel that we could see in the demo at the beginning. If we want to skip manual configuration of filters, we might use the function autofilter from shinyCohortBuilder package that scans the data registered to the source and attaches the filters definitions to it. So let's try this example. And while defining cohort, because the filters definition was registered to the source, we don't have to place it directly here. It will be inherited by the cohort. So running the GUI, we will see that we have all the possible filters for the whole dataset. Another cool thing with the autofilter is that we can attach the filters not as a first step, but as a metadata, and then with the new step argument that is passed to GUI as a value configure, we will be able to manually configure the filters based on the ones stored in the metadata. Let's check it here. Yeah, after clicking add step, the model shows up and we can decide which filters do we want to have in the step. So now if we want to apply CohortBuilder to our custom Shiny dashboard, it's just enough to use two functions. CBUI, which is the module output that we place in the application UI, and for the server, in order to call the module logic, we just place CB server with the same ID and passing the cohort to it. And that's simply it. Yeah, the configured cohort is on the sidebar panel and rendered output to the right. As for the last example, I represent CohortBuilder DB extension. This is the package that allows to use CohortBuilder with the remote tables stored in the Postgres database. So let's load the package. Let's connect to the database. And while establishing the source, instead of passing tblist, we are passing dbtables object, which is creating the list of connections to the precise tables. And the cohort configuration itself is unchanged. So now let's run GUI on the cohort. As you can see, it's a little bit slower than the standard solution, but all of the computations, computing the statistics, generating the charts, is performed directly on the database. So you might want to use it even with the large tables. Yep, that worked. Thank you.
CohortBuilder offers extensive features, including native Shiny bookmarking support, value mapping, attrition plots, and comprehensive documentation to explore advanced functionalities. Do you want to build your Shiny apps faster? Try CohortBuilder now! It's free, it's open source, available on CRAN, you can build internal or external extension, you can test your filtering logic, and be sure that you get the same results in the interactive layer. Build your apps faster! Any contribution to the CohortBuilder are welcome. It's make great opportunity for you. So, what next? We have planned for more advanced filters, UX and performance improvements, backend computation, high-level layers for making adoption easier, templates following the use this concept, extensive validation, and of course we want to collect your feedback, so please share your idea over the GitHub issue. Thank you everyone for being with us.